Notes is covering solutions and how solutions form and some special attributes that solutions have. So just as a review, you want to know that a solution is a homogeneous mixture, which means that it's completely mixed. You can't see the different phases or any different components in it. And you have your solute, which is the smaller amount, and your solvent, which is the larger amount. Typically, we look at the solvent being aqueous, but your solvent can be lots of different things. It can be solid, liquid, gas form, and again, we're going to primarily focus on the liquid ones because those are the most common. But if you take AP Chem or you take Chem in college, you'll see different ones. So just a couple little quick questions here. If you have coffee or tea, which is going to dissolve faster, granulated sugar or sugar cubes? So you want to take a second and just think about that one. And hopefully you circled granulated sugar. And the reason, we'll talk about that in a little bit. And other one, does sugar dissolve faster in hot tea or iced tea? So you want to think about that for a second as well. And hopefully you did hot tea. So there's a couple of different factors that can affect the rate of a solution formation, so how fast something dissolves. It doesn't change if something will dissolve or not, but it just changes how fast it will. So the first thing is surface area, so that's like the granulated sugar versus the sugar cubes. The more surface area something has, the more area that the water can or solvent can interact in it, and typically the quicker it dissolves. Temperature also has it. Typically higher temperatures dissolve faster because the water molecules are moving quicker. And just stirring it because you're forcing the molecules to interact. Solubility is something that basically do the two things you're trying to mix interact well. And we're talking on a molecular level. And there's a lot of different reasons why something will interact or not, which is kind of beyond the scope of this course. They're called, we mentioned them before, intermolecular forces. Just how do they interact well, do they not interact? But if something is soluble, then you can make a solution. If it's not soluble, then you can't make a solution with it. And we'll actually look a little bit more into what's soluble and what's not soluble next unit. So if something is soluble, you can have three situations. You can have an unsaturated solution, which contains less solute than is possible. So like basically you could dissolve more into that solution if you wanted to. A saturated solution contains the maximum amount. So if you can dissolve 60 grams in a certain amount of water, then that's how much is dissolved. Like no more would happen. And if you look here, if you put 30 grams into 100 mils of water of salt, it's unsaturated because it's not, you could still dissolve more. But when you see 40 grams, you've now hit the saturation point because you can only actually have 36 grams per 100 mils of water. So 36 grams of salt dissolved, and you can see down at the bottom here, 4 grams just sat there because like we're at our saturation point. You just can't have any more. A supersaturated solution is an unstable one. It's a pretty interesting situation. So it's an unstable solution that somehow you got more solute to dissolve than you should be able to. So if we're looking back at this salt solution, maybe we got 40 grams to dissolve, or maybe we got 50 grams to dissolve. Typically, the easiest way to do this is you heat up the solution. When you heat something up, it typically can hold more solute. So you add a lot of the solute, you dissolve it, and then basically you slowly cool it down. The real world example is just basically how they make rock candy, and that's one of the major ways that they do it. And there is a video clip you're going to watch. It's really cool. It shows you, it looks like just a regular solution, and then what they do is they put one little tiny seed crystal in, and it's super saturated and you don't know it, and it totally crystallizes in like 5 seconds. It's pretty interesting that you'll see. There's also certain liquids that are totally able to be mixed in any amount. There is no real solubility. And if you're totally soluble, like infinitely soluble, you're called miscible. And just a couple examples of that is ethanol and water, water and ethylene glycol, and ethylene glycol is commonly what you know as antifreeze. If two liquids basically just do not mix at all, they're called immiscible, and the classic example of that is oil and water. So solubility is like kind of in between them. You have miscible, which is like infinite. You have immiscible, which is like not at all, and then the solubility is in the middle. There's some things that affect how soluble something is in something. So we said before, temperature affects how fast something dissolves, but it also affects how much can be dissolved. So typically for solid things, as your temperature increases, your amount of solvent increases. And there's actually a solubility curve, and you can see here, it's at the end of your notes, but it is in here, and you can see lots of different salts and how they do over temperature. So you can see most of them, as we go across an increased temperature, most of them we slope upwards because we have more solubility. There are some weird ones. Hydrochloric acid goes down, ammonia goes down, and SO2 goes down. But for the most part, the trend is that as you increase temperature, typically the amount of solvent you can have also increases. Pressure, typically pressure doesn't really have any effect on solids and liquids, but it does in fact affect gases, and this is one of my favorite examples here. So if you apply pressure to a liquid, gases actually get more soluble. And this has to do with scuba diving. This is why you have to have regulators and you have to have stop points. Just for example, at Penn State, if you take the course to become scuba certified, it actually counts as a science course and as a gym class because there's so much chemistry in it. But this is just a nice example. When you have a 2-liter bottle of soda, there is pressure applied, which is why when you just buy the 2-liter soda, it doesn't look like there's very many bubbles in it. When you open up the lid, you depressurize the situation. So the pressure goes down, and that means the solubility of the gas goes down. And that's how you get all the bubbles, and that's why eventually your soda goes flat. So I'm just going to cut this into 2 sections, but we're going to do a little bit with a dilution equation, and then just look at a couple more things, and that's it for solutions.